Yeah, thanks, Robert. Thanks, everyone, for having me here. Yeah, I'm Jess, and I'm going to talk about performance with React. But who am I? I'm Jess. I got a job in a startup about 5 years ago, and that's what got me interested in programming. And then after a while, I quit my job in the UK, and I did a boot camp in Amsterdam, because it was a bit cheaper to do it over in Amsterdam. But then actually it's quite an expensive city, so I'm not sure if I saved that much money, but anyway. And then I took part in Rails Girls Summer of Code, which is a really nice fellowship for female programmers, and you work on an open source project for 3 months, and it's funded. And now I've been working as a React developer for about 2 years. And I work for FutureLearn, which is a digital education platform. And one more thing about me is that I like drawing pictures of fish. This is an eel, and I like eels because I'm from Cambridge. And Cambridge is very nearby the Fens, which is where this marshy, flat land is, and where eels thrive. But enough about eels. This is what we're going to look at today. Virtual DOM and reconciliation, how to test the performance of your app, shouldComponentUpdate, pure component, React..memo, hooks and performance, array modification threats, windowing techniques for long lists, React.Lazy and Suspense, and analyzing your bundle. So, yeah, I'm wondering if these topics look familiar to you guys. Maybe you can just raise your hand if you've seen them before. Yeah, look familiar? Okay, nice one. So what is what is performance anyway? Well, it's a huge topic. It's dependent on all kinds of different stuff. It's like the hardware of your user, their connection speed, and all kinds of things that we don't really have any control over. But as front-end developers, what we do have control over is like the size of our bundle, how our bundle behaves, and also when it comes to React, how many re-renders we have. So these are Mozilla's web performance guidelines. An initial page load should be between 0.5 and 2 seconds. A response to a user input, like a scrolling or a button click, should be between 50 and 200 milliseconds. And then anything that takes longer than 1 second to load, you should see like a loader or a spinner thingy. And in most browsers, the screen will re-render every 16.7 milliseconds. That's the same as 60 times per second. So that means that for animations that you display, your speeds should be every 16.7 milliseconds, or 60 frames per second. Or should it? Because in practice, 100 milliseconds will still feel responsive to a user. That's 10 frames per second. So the way our human brains work, if you see an animation 10 frames per second, it still looks nice. But the thing is, if you've got animations that take longer than that, longer than every 100 milliseconds, then your user might experience jank. What is jank? Jank is stuttering, juddering, or just plain halting that users see when a site or app isn't keeping up with the refresh rate of the device, of the browser. That's according to jank.com. Who cares? Who cares about jank? Who cares about performance? I'm working away on my React components. They look good to me. Why should I care about this stuff? Well, the reason is that we're probably all developers and designers here. We're probably all working on really fancy, fast computers, but your users are probably not, and they're probably going to notice performance issues that you don't, and that means they're not going to click that call to action, and they're not going to give you any money. But I thought React was fast. You're right, React is fast, but the reconciliation of the virtual DOM is a bit expensive, actually. What is reconciliation? So basically, React limits the direct manipulation of the DOM by maintaining a virtual DOM. And then any update to your site triggers this reconciliation process between the old and the new virtual DOM. And this reconciliation between the new and the old virtual DOM can be quite expensive, even if nothing in the actual DOM changes. So the idea is if you stop that reconciliation happening when it's not necessary. What is the virtual DOM? It has nothing to do with Jamiroquai. Yeah, the virtual DOM is basically a JavaScript object which React builds to maintain a representation of the user interface. So it does this to make sure that React only updates when it's absolutely necessary, when something has changed, and this is what makes React fast. So let's imagine that this is a bunch of components. You've got C1, which is a container, C2, C3, C4, C5, C6, C7, they're all the children. Let's imagine something changes in C1, maybe a state update or something like that. How many of those children are going to re-render? Anybody just shout out. Which are going to re-render? Yes, very good, at the back. Yeah, they're all going to re-render. So if something changes in the parent, everything downstream is re-rendering. Okay, what about if something changes in C2? C1 stays exactly the same, but something changes in C2. Which are going to re-render? A bit louder? Yeah, C4 and C5. Okay, so the others won't be affected, but if something changes in C2, C4 and C5 will change. Okay, so the basic point here is that even if something changes in C1 that doesn't really affect any of the children, maybe it's just this tiny prop that doesn't even affect the other components, you're still going to get those re-renders. So these would be wasted re-renders. Let's see an example. So this is an app, a site which displays some data about animals in a table. There's a parent component called table, and children components called header cells, rows, and cells, which are passed into, the rows have the cells as the children. And then when you update this theme, if you update this theme, then everything re-renders, all the children. So now I'd like to introduce you to why did you update? It's a package which logs potentially unnecessary re-renders to your console. It's super easy to install. You just npm install it and then put it in your root file. Yeah, so you just call it in your root file, and then you can log your potentially wasted re-renders. Yeah, so you're updating the theme, and then they're logging there. So in that cell component, you've got exactly the same data that's before and after that re-render. So it's like, was it really necessary to re-render there? And another tool you can use is one called React Profiler, which is in the React Dev Tools. And you can measure the speed of your React app with that. It's very similar to like the Chrome Dev Tools, but I think it kind of makes the information a bit easier to digest because it's a bit simpler. And there are two phases that it shows you here. You've got the commit and the render just there in the right corner there. And what happens in the render phase is that's where the reconciliation happens. So it's like new virtual DOM, old virtual DOM, is there a difference? And then the commit phase is when the actual DOM is changed. So maybe new components are added, new components are taken away, something's updated. And you can see a visualization of how long each component took to update. So you've got the slowest at the top and then the fastest at the bottom. So let's look at Profiler app for this. So you can just do a clear the cache and refresh, and then record what's going on. You make a change to the UI of some kind, and then you stop recording. So in this case, we've got a commit of 2.3 seconds. That's when the actual DOM changes. And then the render is 7.9 milliseconds. That's when the reconciliation is going on. So I wonder if we can make this faster. Okay, you can use shouldComponentUpdate. Is that familiar to anyone here? Yeah, nice. So yeah, you can return false for certain props with this if you know that your component shouldn't update. So let's imagine that there's a change in C1, and in C2, we've got shouldComponentUpdate. Which of the children are going to re-render? Anyone can shout. C3, C6, and C7. Yeah. Okay, because shouldComponentUpdate is returning false, so it's stopping C4 and C5 re-rendering. Yeah, so in the example I just showed you with the animals app, maybe we can put shouldComponentUpdate in the rows, and then that will stop the rows and the cells re-rendering. We could maybe also put it in the container in the table, but the problem with that is that shouldComponentUpdate can be a little bit difficult to maintain. So maybe you'll come in and add some other props later on, and then you'll wonder like, oh, wait, why isn't that updating? Because you've forgotten you've put a shouldComponentUpdate in there. So yeah, it has some drawbacks. Maintaining code with shouldComponentUpdate can be a bit tricky when you've got a new prop and then you're wondering why it's not updating. But the most important thing probably is that the performance gains are often a kind of insignificant as well. So only use it if you're already sure that you're getting a benefit. Another option is pure component. So you can use a pure component on a class component instead of your regular React extends component. And that's clever because it does shouldComponentUpdate under the hood. So that basically means that a pure component is listening out. Are there any props that are changing? Are the props changing? If it is changing, then it's going to make that re-render. So you don't have to worry about if you've got a new prop being added later on. But one thing is that it does a shallow comparison. So it only compares two variables in a shallow way. So if you've got nested data, that can be a problem. What is a shallow comparison? Imagine we've got three objects, x, y, and z. X and z are actually the same because they have the same key and value pairs, but y is different because b equals 3 instead of 2. So y is not equal to z, and that's what you'd expect. But also x is not equal to z because it's not worrying about what's inside the object, it's just looking at the variable name. And then if you changed yb to 2, then y is still not equal to z because it's just looking at the variable names. And then, but the thing is, if you reassign y to z, so you're like, okay, now y is just the same as z, then y does equal z according to shallow comparison. And then even if you start changing b again and putting it back to 3 and then adding some other random key value pair to y, then y is still equal to z according to the shallow comparison. So maybe we could put a pure component in that table, and then that will stop re-renders downstream. Some things to watch out for with pure component. Yeah, you can only use it for class components, stateful components, and it implements that shouldComponentUpdate with a shallow comparison. So maybe if objects with lots of nested data, be careful, and also be careful using it with this prop's children, because the way it works is that pure component will always think of this prop's children as a new prop, because it's regarded as a new object, even if no props change. What about functional components? For functional components, you can use React.memo. It's a higher order component, and it gives a performance boost by memoizing the results of that function. It's very similar to pure component or shouldComponentUpdate, and it also shallow compares variables. What is memoizing? Great question. In computer science, memoizing is a technique used to speed up programs by basically storing the result of an expensive function, basically caching the result of the function, and then it returns that cache result if the same expensive function with the same parameters is called. So maybe we can put React.memo in those child cells. So let's test our app again. Okay, so we've got pure component in the container table and then React.memo. Let's see. So we don't get any why did you update in the console. We don't see any of those wasted re-renders. And then we can record with React Profiler. Change something, click stop. So what have we got? We've got a commit now of 1.5 seconds and a render of 1.1 milliseconds. I recorded these, but I promise I didn't Photoshop them. And yeah, if we compare it with last time, so the commit is 8 seconds faster, and the reconciliation phase is 6.8 milliseconds faster. So maybe that's not a huge deal, but imagine like you've got a huge app with loads of components, loads of data everywhere, instead of just this like table of animal stuff. Maybe that's going to make a difference. React.Memo also has some caveats. It's basically like using shouldComponentUpdate, but always set to false. But what you can do is you can pass in a second parameter that's a function that checks if the previous props and the next props are equal. And you can also use React.Memo on components that have children, but just make sure that those children don't have props which are going to change or which need to change and update. What about hooks? Yeah, so what do they mean for performance hooks? Well, hooks don't actually add any new functionality, but there are some performance benefits in using hooks. And this is because hooks tend to kind of minify a bit better. In class components, the lifecycle methods are not minified, and unused methods are not removed from the build. One hook you can use is useMemo. That also memorizes the results of the function and then returns it. And then if something changes in the list, in that second parameter, then it will update and do the call again and return something new. Otherwise, if nothing changes in list, then it will just return what was cached. You can also use callback as a hook. And the difference between useMemo and useCallback is that useMemo returns the results of the function call, but useCallback just returns the function to be used later. Yeah, so that can also be helpful. What else can I do to improve performance? Maybe you've heard enough of methods and hooks now. What else can I do to improve the performance of my app? One of the things to watch out for is lists. So when you create a list with React, you should always pass in a key, because that helps, that allows React to kind of work out and identify each item in that list. It can be really tempting to use index, but the problem with that is basically index is like your order of items, first, second, third. So maybe that list is going to change, or maybe users are going to want to delete items in that list. So it's better to make that key like a string, maybe a string, or like maybe a data ID, like from your database. Something that's totally unique and it's not going to change. And this is because if the list rearranges, if someone deletes stuff, then it's not going to cause problems. So if you do use your index and things change, maybe it'll break everything, maybe it'll just ruin performance, or maybe you'll just see the wrong data. So the key is only use your index for keys if you know that list is never going to change. One other thing is windowing technique for long lists. It's also called virtualization sometimes. And the idea of this is like if you've got a really long list of data, then maybe you only want to render, like maybe you only want to load what you need to render immediately. So it'll only show that window of list that is visible to the user. And there's two main libraries you can use for this. React Virtualized, that's like an older one, it's a bit larger. And then a more recent, lighter one is React Window. So I'll give an example here. So on the right, you've got the non-windowed list. It takes a bit longer to appear, but then the scrolling is faster. And then on this side, on the left side, it loads a bit faster, but then the scrolling is a little bit on the slower side. Yeah, and then another problem with like a big React project is like if you've got a huge bundle of JavaScript containing loads of libraries, it's going to take ages if that all needs to load before you see your first page. So what you can do is split your code and then lazy load items as and when they're needed. And then while your component is being lazy loaded, you can use Suspense to render a fallback component. And then this fallback prop accepts another component, like a loader or a spinner or something. Here's an example. So the loader is passed into suspense component as a fallback prop, and then you get that component lazy loaded. Another thing you can use is Webpack bundle analyzer. It's super easy to install. Just npm install it, and then adjust your Webpack config and run production. Does anybody recognize this visualization? Yeah? Nice. Yeah. So this shows your bundle, basically. It shows what's going on. So maybe here, like, do I really need Lodash? Maybe I'm just using it in a couple of places. Maybe I've got duplicated libraries here. Maybe I'm using 2 libraries that basically do the same thing, like datefns and moment, both handle time. Maybe I only need 1. Maybe I can even use something other than React, like something lighter, like Vue or Preact. There are also some micro-optimizations. Fragment can help you avoid unnecessary divs. Remember to use the production build of React on production. I've been guilty of not doing that. Resize all your images to a minimum size, keep them small. Don't call functions in the render method, do it in a separate method. Okay, and now is the time to wake up if you've fallen asleep. What did we look at? Virtual DOM and reconciliation, how to test the performance of your app with shouldComponentUpdate, pure component, React..memo, hooks and performance, array modification threats, windowing technique, React.Lazy and Suspense, and analyzing your bundle. And here are the key takeaways. Before making performance improvements, use React Profiler or why do you update. shouldComponentUpdate can stop wasteful re-renders. Pure component can be used for class components. Memo can be used for functional components. But most importantly, don't just randomly add stuff willy-nilly. Like, test the performance. If making a change gives you a gain and increase, then implement it. And thank you. That's it from me.